In this video, we're going to apply transformations to reciprocal functions. To begin with, let's recall that the base reciprocal function is f of x equals 1 over x. So therefore, the general form of the reciprocal function, we replace the x with b times x minus h. In the base function, x is in the denominator when 1 is the numerator. So again, 1 is going to be the numerator. We then put that in brackets and multiply it by a and add v. So we're asked to graph the function f of x equals 3 times 1 over 2 bracket x plus 5 and bracket all minus 4. So first, let's describe the transformations. So we can see that the a value is 3, so there is a vertical stretch of factor 3. The b value is 2. So b equals 2, which means there's a horizontal compression of a half. Even though the 2 is on the denominator and this looks like a half, the 2 is multiplied by x minus the h value. So in front of the x minus h is 2, so that means b is 2. It's in the bracket of lie, so it's a horizontal compression of a half. The h value is negative 5, which means there's a horizontal shift 5 units to the left. And the v value is negative 4, which means there's a vertical shift 4 units down. Sometimes you will see questions that multiply the 3 to the numerator in the fraction. So it looks like this, 3 over 2x plus 5 minus 4. If you get a question in this form, it's good to bring that 3, that numerator, outside, so you have the 1 over the bx minus h. And then you can clearly see that the a value is 3. It's a little harder to see when the question is written this way. So step 1 is to graph the base function, which is f of x equals 1 over x. When graphing transformations of the reciprocal function, you only need to show the point 1, 1 and the point negative 1, negative 1. You don't need to show any other points, and that is because the asymptotes will help guide how that function looks. So we should discuss the asymptotes. So remember, you have a vertical asymptote along the y-axis, which has the equation x equals 0, and you have a horizontal asymptote along the x-axis, which has the equation y equals 0. So you need to include those 2 points clearly, the asymptotes, and then your 2 sections of your graph, make sure that they do not cross or touch or bounce off the asymptotes. So step 2, we are going to apply the a value of 3 and the b value of 2. So we are going to apply that to the point 1, 1, and also the point negative 1, negative 1. So let's look at the point 1, 1. When this is vertically stretched by a factor of 3, it's now 3 units away from the x-axis up here. But then when it's compressed by a factor of half, it's horizontally compressed. So instead of going over 1 unit, it's now over half a unit. So my original function is this purple function, my base function, but my transform function is this black one. So I have a point right here. And now let's look at the point negative 1, negative 1. Again, it's 1 unit away from the x-axis. So now we want to be 3 units away from the x-axis. So it's down here. And now horizontally, this point was 1 unit away, but now we want to be half of that away. So we're now going to be at negative 0.5, negative 3. So before we draw this function, again, we need to consider the asymptotes. Asymptotes are not affected by horizontal stretches or compressions. So here our asymptotes are still x equals 0 and y equals 0. So you would make sure that you go through your new transform point, be very clear to show that point, those 2 points, go through those 2 points, and then hug your asymptotes. And we just graph the function f of x equals 3 times 1 over 2x. So now we can apply step 3, which is applying our shifts. So we are going to take the 2 new points that we have and move them 5 units to the left and 4 units down. So this point here, when we go to the left, 1, 2, 3, 4, 5, 1, 2, 3, 4. We end up right here. And this other point, here we go, 1, 2, 3, 4, 5, 1, 2, 3, 4. So we end up right here. Plotting those 2 points is not enough. We also need to know where our asymptotes are. Vertical asymptotes are affected by horizontal translations, left, right, and horizontal asymptotes are affected by vertical translations, up and down. So here x equals 0. When we move it 5 to the left, now has the equation x equals negative 5. And the horizontal asymptote y equals 0. When we move it down by 4 units, our v value, we now get an asymptote at y equals negative 4. So we can see our point, we can see the 2 asymptotes. It's going to have the shape of this black reciprocal function, and all we've done is just moved it. So now, so that point and that point, as well as the asymptotes, is enough to draw this reciprocal function. One arm of the function is going to be up here and hug the 2 asymptotes up here. And the other arm we can tell is going to be down here and go through the points. Be very careful not to touch your asymptotes. And then finally just label the function.